So everybody knows what he's talking about with the y coordinate? Everybody already figured that out?
I'm not even there yet.
Okay, so when you're drawing, this is the origin. This is considered 0, 0 down here in the bottom left-hand corner. And however big your window is, this is considered width height.
The max.
The
So
max,
right
okay.
now it's 500, 700.
Okay, so that's your coordinate system for drawing. On the other hand, the mouse, when you get mouse events, this is the origin, 0, 0, and this is the max value. So if you get from the mouse, you get a particular coordinate, x, y, the user clicks, then what's the, let me call it x prime, y prime, what is the drawing coordinate that corresponds to that x and y coordinate that was the mouse was clicked? So, in other words, if you have the mouse coordinate, x, y, then how do you calculate x prime and y prime?
I just took the screen size and subtracted y from it. And it worked.
Sorry?
I took the screen size, so basically height, h minus y gave you a proper number.
Okay.
I'm having trouble figuring out the radius for my circle. I've got the equation. It's x1 minus y, or x2 minus y1, or x2 minus x1 squared.
The equation of a circle?
Yeah, the equation to find the radius when you're given two sets of coordinates, two ordered pairs.
Okay, so somewhere on the screen you're given, I'm using screen coordinates now, you're given x1, y1, x2, y2. And you want to know the radius so that you can use this as the center and draw a circle around there.
Exactly.
Okay?
And I know the equation, but I don't know if I'm setting it up properly.
So the equation is
The square root of x2 minus x1 squared plus y2 minus y1 squared.
okay, so if that's the equation you want to calculate, now you need to actually do that in C++.
Yes.
That's the issue?
That's the issue.
Okay, so first off, let's assume that you have variables x1, or x2, x1, y2, y1. They're already set with the correct values.
Mm-hmm.
And they are int or double?
Doubled.
They're doubles. Okay, so they're doubles. So I would probably proceed in this fashion. Get the difference between the two.
Okay.
Do that for both x and y. This is our calculus coming into play, right?
Yes.
The calculus influence. Use dx and dy. Maybe?
Yeah.
Okay, so from there I need to get the square of dx and I need to get the square of dy. So the square of dx is just dx times dx. The square of dy is dy times dy. Right?
Yep.
And I want the square root of that. So just use the square root function, which is conveniently called SQRT. See what your first guess when you're looking for the square root function. How to spell it.
Yeah, it's SQRT.
Right. And I'm putting it inside of STD because I'm assuming an include of CMath. So the square root function is part of the C math library. Will be included in that fashion, and we're not using namespace. We have to say STD function. So that should be able to calculate the radius in as a double. Square root function works on doubles by naturally, so it should work correctly.
We'll find out.
Other issues on our shapes?
I don't even know where to start with the main function. I mean, I didn't realize that when he said we use graphics1.cpp as the main function, main.cpp. Like, yeah, I didn't realize that, so I didn't get very far on main.
So yeah, that's where? Surely I had.
Wasn't that in Windows?
Yeah, I was working on Windows, but I thought I'd saved it in this folder here. So we'll look at it from here anyway.
That was it. Fixed it.
Okay. So to start this program, first off, I wouldn't start from scratch. I'd just take that starter kit that we had, download it. It's a Windows project already. If you're not working in Windows, which is how many?
Well, for this I am, which is confusing in itself. But
Okay. So if you're not going to work in Windows at all, then we're going to have to figure out, there's some links on the CS3005 page, the graphics programming class on getting the development environment working for LUT and GL under Linux.
I can do it.
So, and I'm sorry, I haven't converted and made a starter kit for both platforms. But it's not a big deal, switch to Windows for these next few projects that are doing in this. Okay, so if you download this, I would recommend that you just start with this and take this project, which draws the three shapes by default, and just make modifications to it. Add your classes directly to this project. Don't try to copy the code out of here into another project you start from scratch. The reason for that is this has all of the libraries that you need to link in. They're already configured to be linked in correctly as part of the build of the project here, so it'll be a lot easier for you to deal with. So when you run one of these graphics applications, all of this initialization code sets up creates your window of the correct size and all that kind of setup for you. Down here, these functions right here are your interactivity functions. It's been a while since we walked through this, but this display function, this is the name of a function here, right? There's no parentheses after it. It's not a function call. It's the name of the function to be called when the display needs to be redrawn, when the graphics need to be recreated. This function here is the function to be called whenever the user presses a key or left up on a key. This is the function to call whenever the user stretches the window, changes its size, reshapes it. And this is the function to call whenever the mouse moves or is clicked on your window. Actually, I take it back. This is only clicks. If you want motion, we have to add a mouse motion function. Okay, so these functions are where you're going to configure your interactivity, what to do when the user does something, and how to display the results of your data. So you should consider using initialize my stuff, this function. This is a function call, right? So after all the configuration happens, initialize my stuff is a place to one time run the startup configuration of your code to get it all ready to roll. After which the main loop is entered, and the only way you have of interacting now after main loop is entered is when your functions are called by this main loop. The main loop just watches for if the display needs to occur or if any of those events happen. Is that okay?
yeah.
Okay, so initialize my stuff. the way I would proceed is like this. Where is this over here? So the initialize my stuff function is just for the one-time setup of your code. So I would do whatever I need to do to set up my variables. For example, you're going to be drawing circles and triangles and rectangles and so forth, right? So you're probably going to be keeping lists of them, right? Because you might have multiple circles, multiple rectangles, multiple triangles that you need to draw. So you probably want to start the program off with an empty list to say that you don't have anything to draw before the user actually creates graphics to be drawn. Okay? So set up your variables. Now the problem is, any variables you create inside of this function are local variables. They're on the stack. They'll go away as soon as the function leaves, and you don't want them to go away when the function leaves, right? Okay, so at the top of your program, outside of any functions, you'll set up whatever variables you need globally. So let's say that you're going to keep a list of circles. Up here in your global section, you'll actually say list of circles, whatever type it is, type whatever list of circles is. And down in here, you'll make sure you initialize it so that it's 0 items in it. It's empty. It has no items contained. Okay, when I say global variables here, I'm talking about right at the top of the file, right? Right up right here. Now, global variables are evil and bad. We don't like them, but sometimes they're necessary. So, little note here, only what you need. Don't put all of the variables you're ever going to use in this program up here. Still keep local variables where they can and make sense. But your global structures, the entire data set for keeping track of the shapes and information you need to keep working, can go up here, but nothing else. Okay, so initialize my stuff will set up your empty list and so forth. Then, the mouse function. I'm sorry I'm not writing pure code here, just sketching things. The mouse function takes no parameters, right? So it's got an empty parameter list. Inside of here, what are you going to do? Let's say you're in circle mode. You're creating circles. What will happen when the user clicks the mouse when you're in circle mode?
It should store where the mouse clicked and then put a circle there.
Okay? You need to store that, right? That's the first click. Now you say put a circle there, but we don't have all of the information to create a circle yet, right? That's only the center of the circle. What else do you need?
The radius.
You need the radius, so you need a second point, right? So when the user clicks the second time, let's say they click over here. Then, given that you already have stored the first click, and now you have the second click, at that point, you can calculate the radius. You know what the center is. The radius over there, this is the center right here. And now you can actually create a circle, right? So, inside of the mouse function here, you're going to be looking for first click. You're going to be looking for second click. When it's the first click, you're probably going to save the click coordinates. When it's the second click, you're going to create a circle, which means you're going to have to push it onto your list somehow, right? Add it to your list that's in the global area. And then you'll probably want to clear out the first click. Because you want to be able to know whether this was the click that's determining the center or the click that's determining the radius of a circle, right? So you'll probably have a global variable or global variables that you're using to track whether or not this is the first click or the second click when you come into the mouse function. And you have to maintain its state from within the mouse function. Is that okay?
Mm-hmm.
All right, so that's if you're always in circle mode, right? Well, if you're in rectangle mode, then it's similar but slightly different. In rectangle mode, you have a first click and a second click, and then you create a rectangle out of it. So it takes 2 clicks to make a rectangle. If you're in triangle mode, you actually need 3 clicks to be able to create a triangle. So you need to actually save the first click, save the second click, and then on the 3rd click, you create your triangle and clear your clicks out. All right. Now, we did not specify the layout of your user interface, but we did say, I believe, that you're supposed to have buttons.
Radio
Yeah.
buttons.
They call them radio buttons, right?
Right.
Which means only one of them can be selected at a time. So I expect to have a circle button, a rectangle button, and a triangle button over here, and one of those will be activated. That's the mode you're currently in. When the user wants to drive triangles, they'll click on the triangle button, it becomes active, and the circle and rectangle are inactive, and then you wait for 3 clicks and create a triangle. And as long as the user keeps doing those 3 clicks, every 3 clicks they get a new triangle. If the user goes and clicks on the circle button, then you go to circle mode and you're no longer in triangle mode, and 2 clicks gives you a circle. And you keep adding either to your circles or your rectangles or your triangles. So all of that has to happen with the mouse. You have to be able to recognize if one of these buttons has been clicked on as well inside the mouse function. All of that is maintaining some global variables that track the state of your system. Which mode are you in and how many clicks have you received? I would recommend when you change modes, you clear out any clicks. So if you're in triangle mode and the users click twice and they click the circle mode, don't create a circle with those 2 clicks. Clear out the clicks and make them click twice to create a circle. That'd probably be more what the user's expecting, right? Okay, you shouldn't have to deal with the reshape function. Shouldn't. The keyboard function, if you decide to add keyboard shortcuts, like the user types a C and it instantly goes to circle mode, then you would implement it in here, and so you'd just be manipulating the global variables again. Finally, the display function. That's the other big modification that you'll have. So in here, you basically loop through your shapes, drawing them. Shapes are stored in these global variables, right?
So we just loop through the lists and our global variables and draw them.
Yep. Now, if you've spent any time in a vector graphics application, you probably have an intuition that if I create this triangle and then I create this circle, that this circle should be on top of that triangle, right? If I then create an additional triangle, then this triangle should be on top, this circle should be on top of that triangle, and this triangle should be included partially, right? So stacking order matters, right, in what the user is expecting to see. So if you have a list of triangles and a list of circles and a list of rectangles, and you loop over each of those lists and draw them, well, the way that the graphic system works is the last thing drawn is on top. So you would actually, if you drew triangles first and then circles, then this wouldn't work, right? Because this circle would include part of this triangle here. And if you did circles and then triangles, then it wouldn't work because this triangle would include part of that circle. So you want to preserve the order So you actually can't keep 3 separate lists, you need to keep one list of all of your shapes. And so you would actually only need one loop in your display where you loop over all of the shapes and draw them in the order they were created.
And so we want a list of shapes, not a list of squares, circles, right? And that's why we have the constant.
Right. So they all inherit from shape, right? Okay. So now if you have a list of shapes, well, that's not going to work because a shape doesn't have all the information that a circle and a triangle and a rectangle have, right? Those are specializations of the shape class. And so you need to implement polymorphism here. So instead of having a list of shapes, you're going to have a list of shape pointers. Shape star. So when you're down here inside of mouse, you're going to do things like new circle and create a circle object, right? That gives you a pointer. You're going to take that pointer and append it to your list of shape pointers. This will be the derived class. You can take a derived class pointer and store it anywhere you would store a base class pointer. If you correctly define your methods and you use virtual so that polymorphism can occur, then when you're in here and you call shape pointer arrow draw, then the draw mechanism will work correctly for drawing a circle or a triangle or a rectangle, whatever it is you're trying to draw. Now, let me talk about complexity for just a minute. There's 3 assignments here, right? This is a 3-week assignment, step after step after step. So the end goal is to get everything that's in all 3 of them by the end of the assignment sequence. If you first implemented it with 3 separate lists, at least you're implementing so you're collecting 3 different kinds of shapes and you're drawing 3 different kinds of shapes. If you're not preserving the stacking order yet, then that can be fixed, right? So if the stacking order thing is a confusing element to begin with, then don't worry about it and have that part of your program broken, but at least have it collecting information from the user and storing it. Incremental development is the way we really do things in real life, so it's okay. Just want to make sure we're working towards the end goal, okay? And I would probably start, if I was starting from scratch on this, I would probably not create my buttons yet. I would say, let me get circles working. Actually, rectangles are easy. Let me get rectangles working. And all I would do is implement a list of rectangles and make sure I have my shape class and my rectangle class. And every 2 clicks, the user gets a new rectangle on the display. That's how I would start. After that, then I would say, okay, now let me go back and switch modes. So that then I would go back to add my button and start looking for switching from rectangle to circle. Add my circle class and make sure that I can switch between circle and rectangle. Then add my triangle class and so forth. I add it piecemeal so I can actually see something, get something working as I'm moving along, rather than trying to have this wonderful working set of code that finally I compile it and have my working application. It's never worked for me on a serious application to just develop it in one big swoop. Done enough ranting about the assignment? You guys that have it already done, I guess it's probably boring to talk about it again.
Anyone have it done?
You just barely through them.
The part 1. Okay. Anybody else have it done? Anybody else have significant progress? Is this like week 1 for you on this shapes assignments then? Is that safe to say for everybody?
Pretty much.
My brother.
All right. Well, maybe after today we'll talk about a mechanism for combining the shapes assignments and the follow-on assignment, STL containers. That's the assignment that comes after shapes. You haven't even seen it yet, right? There's shapes 1, shapes 2, shapes 3, and then STL containers. Then we do
Just
connect 4.
Connect 4.
Yours doesn't say STL containers?
No, it goes to shapes 3 and then connect 4 is assignment 12.
Where I was looking at this morning, we had STL containers.
On the schedule it has STL containers, but the
Oh,
assignments doesn't
I'm
show.
sorry, thank you. I'm talking about the assignment list. I'm sorry, the schedules.
Okay.
The schedule.
Then yes, STL container. But it's there's no assignment description.
Right, assignment description's not there yet. But in the schedule, there is that additional assignment. So what I'm thinking is I'm probably, rather than create a brand new assignment for this, roll this assignment into, my intentions for this assignment into shapes 1, 2, and 3. So that basically we can have shapes 3 due on this date.
What was STL containers going to do?
Hopefully we'll get that covered today and Thursday or Wednesday. So.
Awesome.
Okay, so I assume that in your implementation you're using your template, your list template that you created. Bad assumption.
Bad assumption. I'm trying to think of how I did it. I actually didn't use my shape class, to tell you the truth. I have 6 global objects that have been created. I'm directly using triangle, rectangle, and circle classes, because I wasn't sure how to use the shape class.
Okay.
So, but inside those classes I have vertice arrays set up as protected values, and those store the points given to draw the shape. And that's basically where I'm at. The shapes, if I draw a second triangle, the first one disappears. I haven't figured out how to keep it.
Okay, so you don't have a list of shapes yet.
Yeah, that's broken still.
Okay, okay. Alrighty then. So, one way to keep this list of shapes is to use the list template that you created in your previous assignment. You created it and it was able to store students, right?
Mm-hmm.
And then you made it so that, I assume, you made it so that it would store something besides students. As far as your test code went, so you tested to make sure that you didn't have a student-specific code left over in the list template. So one way you could do this would be to make a list of your type that stores shape pointers, and then insert shapes as they get added. And then in your display, you would loop over that list and display each one of them. Okay, that's one way to do it. Another way to do it is to create an array off of the heap of shape pointers, and every time you add a new shape, roll that list by one by allocating a new list, copying all the old values over, allocating a new array, copying the old values across, and then adding to the end. That's another way you could keep maintaining your list of shapes. We're going to look at a different way of maintaining data. Okay, the data that I'm maintaining today is just a bunch of ints. Okay, so I randomly created 100 ints and shoved them into a text file and called the text file numbers.txt. I want to be able to take those integers and store them by growing some sort of data structure, okay, to store them in, some container to store them in. So this example right here doesn't actually store any numbers. It just reads the file and displays the numbers in there. So this is just text file reading. Questions about this? It's a simpler version of what you were doing with your students, right? When you're reading students in. So, if there's any questions, I'm happy to talk about it. Otherwise, this is just a template for what we're about to do. We're going to change so that rather than reading those numbers in and just displaying them immediately, we're going to temporarily store them in some data structure inside of our program. And then after we've read the entire file, then we're going to loop over that data structure and display them out again. So, good to go? Okay, the standard template library has lots of features for us. One of the features it has is a structure called a vector. A vector is a container. A vector is a dynamically resizable container, meaning it can store any number of items as long as you have enough memory on your machine to store them. It's a template, just like your list is, right? So it can store any kind of data as long as you've appropriately defined assignment operators and copy constructors and things like that associated with the type you're trying to store in there. Our example today is just integers, but it would work for student objects or circle objects or whatever you're trying to store. Okay, you access the vector by doing a pound include of the vector header file. You declare a vector object with that statement right there. std::, vector, grabbing the vector class out of the standard namespace, right? The angle brackets, what does that do?
It tells the template list what it's going to be.
Okay, it tells the vector what it's going to store, right? So it's going to store integers here. So my variable is named numbers, and it's going to be a vector of ins. I'm going to erase this over here. Okay, vectors are linear structures. And the model for a vector is a sequential set of items in an array. You can think of a vector as an array. The nice thing about it is that the vector container has methods set up to help you easily grow the array. In particular, if you have a vector and you say vector dot pushback, well, the pushback method takes a parameter, which is an item you want to store in the array. So if my array were initially those 7 values, and I called pushback, let's push back 17. Well, the vector class will automatically allocate a larger array space. It will copy all of the previous values across in those slots that they were in, and then it will add the new value onto the end, and it will call delete on the old copy so that we don't have any memory leaks. So pushback automatically grows the array correctly for us.
That's cool.
Makes things a little easier.
I mean, I know you like new and delete, right? You like playing.
I like using them frequently.
I'm guessing there's a push front.
I think so. We'll check in just a minute. I don't use vectors in that mode, but I think that there is one. So, other cool features about a vector. Well, vector has a method called size. So if you ask it, you say vector.size, it'll tell you how many items are stored. So in my case over here, size would have been 7 here, but it would be 8 here. Right? The number of elements. In Python, you can think len of list, right?
Mm-hmm.
Okay. Then, the other really cool feature about vectors is you can use the array indexing syntax, and there is actually an operator associated with the array bracket syntax. So that method is defined correctly so that you can index in just like you would with an array. So vectors are pretty cool. They're dynamically sizable arrays. You don't have to do any of the mucky-muck work. And that's the short story on vectors. The longer story is it's very inefficient to allocate one item at a time as you're pushing back. And so there's lots of tricks that are built into the vector that it tries to predict. And it actually allocates bigger chunks so that it has space, so it doesn't always have to copy. That copy is an order n operation, right? Mm-hmm. Order n operations, when you really want to just insert one item, is very painful. And so there's other optimizations that it has built into it to try to do better in practice. Okay, if you want to learn more about the vector class, you can do a Google search. There are a couple of common websites. This C++.com is one of them that tries to document all of the standard features of C++. So right here we're looking at the vector class. And within the vector class, here are all of the methods associated with it. And in particular, we had a question about push front. There is not a push front with a vector. There's a push back, there's a pop back, there's the indexing operator here, and there are some other methods in here like size and resize and so forth. So there's a lot more to learn about vectors than that, but basic operations are you're shoving stuff in and you're trying to loop over the things after you got them in.
So it looks like you could push back and then swap with the front. Like, because there is a front where you can access the first one, and then there's a swap. So
that might be doable. Actually, swap takes the vector you're calling it on, and it takes a parameter of another vector and actually swaps the contents of the two vectors.
oh, well, okay.
Not exactly what you're looking for. Clear gets rid of everything. Insert and erase I'm not prepared to talk about today. Pop back removes the last item and it shrinks the size by 1. Back and front do access the front item and returns a copy without removing it, and back returns a copy of the back item.
So it essentially acts like a stack, right?
On the back side of it, with the push back and the pop back, yeah. It's got the stack functionality, but it's not a pure stack because you can actually access randomly any element in the list, or in the vector. Okay, we haven't talked about iterators yet, so don't worry about it. So that's basic functionality of the vector. We're going to look at another data structure. Okay, in addition to the vector, there is a list in the standard template library right there. So you include list, and it looks the same way. It's a container, so you can say standard list int, and it's a list of ints. Lists in the standard template library are doubly linked lists. The list you implemented was singly linked, right? Just forward links. I assume from your data structure class you've talked about doubly linked lists. You go forwards or backwards through them, right? Okay, so this here is not meant to be demonstrating a cool feature of the program, but to demonstrate the features available of the list. Okay, so here as we read in each number out of the file, I randomly choose whether to push it on the back or the front of the list, because you can grow either side of a list. And because it's doubly linked, it's fairly efficient to grow on either side, right? You don't have to move anything. You're just adding a node in at the front or the back. And so here, basically, I flip a coin with each number as they come in to shove them on the back or the front. So push back, push front. Yes?
Since we're using ints here, how would we do like tuples or storing 3 values in a single entry?
So if you're storing multiple values and it's not a class object, if it is a class object, then you're just pushing objects in, right?
You just push the pointers.
So if you're trying to store multiple things, then here you might have a list that you put a vector of ints in. You're talking about pushing tuples in or things like that, right?
Yeah.
Where would we put it if we were wanting to put in objects?
So you're putting in an object, let's say you're putting in student objects,
Oh, God.
or maybe shape pointers. Okay? So again, push back, push front, so you can arrange where you want to push them in. There is no indexing operator for a list. And that's because random access in a list is not an efficient operation, right? You can't access the nth item in a list effectively. You have to loop from the start in order to find that. And so instead, for pulling the numbers out of this list, I am randomly choosing again, flipping a coin, and I'm either grabbing the item off of the back or the item off of the front so that I can display it, and then I'm popping either the item off of the back or the item off of the front. Yes.
Does pop back return the number 2?
It's a void. It doesn't return anything. It removes and throws away the item that's there. It's really quite annoying. It's not the way I would have implemented it.
Seems like it would.
Yeah. So, yeah, pop back and pop front don't return the value, which is why you grab it with the back of the front method first. Okay, and since I'm popping back and popping front every time I grab an item out of my list, then my size reduces every time, right? So I keep going as long as size is greater than 0, as long as there's something in there. Notice that this is different than the vector, and the vector still had all the items in it because I was looping through sequentially. And I was doing random access, I wasn't removing anything from my vector. If we come down here to the documentation, we can go to the list documentation, and again we see a whole collection of methods that are available here on the right-hand side. They're grouped by their kinds of functionality, which is where we see things like pop front. We can go click on it, we see that pop front is a void. And I always forget, in fact this morning when I implemented this code, I put R equals pop front. Compiler said you're not properly ignoring the void return value. And that's right, no one fixed it. Anyway, it does annoy me as well. All right, we have stacks. I assume that you know the functionality of a stack. LIFO, last in, first out, right? So we include the stack, and then we say stack of ints, and we then push. There's no front or back, right, on a stack. There's only one side you can push. So we push something, then we do push. In order to get rid of something, we say pop, and in order to access the item that's available, you do top. The top grabs the item that's on the top, a copy of it, and pop actually throws it away. So it's just like the pop back or pop front. And we've got a queue. Queues are FIFO. First in, first out. So we include queue. You can say standard queue right there, event. So we push again because you can only push on one side of a queue, and we pop because you can only pop one side of a queue. If you're going to get a value out of a queue, you have to say dot front. And that's an item that will be thrown away next time you call pop. Well, vector is but stack and queue are there because they implement those abstract data types that you learn. In some cases, you're not supposed to look in the middle, right? You're not supposed to look inside. So they enforce that structure. But vector can implement any of them. Yeah. It's more general purpose. List, though, is faster in certain kinds of circumstances. Okay, I threw priority queue in here. Have you started studying priority queues? Heaps?
No.
Okay. A little bit? Okay, let's just say, I'll just say this. The priority queue, you push and pop, and you can look at the top. The difference here is it's not FIFO, it's not LIFO. Where you push all your items in, and when you pull them out, it'll pull out the largest item that's in your queue. So it pulls them out largest to smallest.
So it's almost just like a sort.
But it's not sorted. And if you guys haven't covered the details of heaps or priority queues, then I can't cover it in the negative 10 seconds we have left in class. But it's more efficient than completely sorting if you only need to grab the smallest value or something like that, or largest value. Anyway, there's a little bit more I want to show you on this, and I hope to give you an example on Wednesday using these.